In the CRF pilot scenario, we target the automotive industry to realize the objectives of sustAGE. Our main goal is to enhance occupational safety and wellness of assembly line workers by capturing their body motion and identifying a set of abnormal body postures performed during assembly actions that contribute to increased risk of body stress and in the long term may affect the development of musculoskeletal disorders. The CRF vision module relies on visual data acquired by 4 stationary cameras installed at fixed positions on both sides of the door assembly production line at the CRF workplace. Each sensor acquires synchronized sequences of stereo images and depth data. We apply markerless 3D body pose estimation for each line worker in real time under challenging conditions in the CRF working environment. For each workstation, we utilize visual data acquired by 2 cameras that are located at the inner and the outer side of the working area in order to avoid severe long-term body occlusions. Our module analyzes the 3D body motion to identify the occurrences of 4 types of abnormal body postures during the door assembly cycle and classify them into 3 levels of ergonomic risk. Red is for high risk. Each posture type focuses on the musculoskeletal stress imposed to specific body parts or joints, i.e., arms, waist, or knees. A system message is sent to the universal messaging bus by the CRF Vision module at the end of each assembly cycle execution, summarizing the set of detected abnormal postures. As shown in the dashboard, APAMA aggregates these messages for 6 and 36 consecutive assembly cycles per workstation to estimate the overall musculoskeletal stress as an ergonomic risk indicator. Alert messages are finally issued to the line worker by the recommendation engine.